The determination of an irregular unknown, a Dr. Kelly reaction. Let's start with a very simple observation and fact. In order to use water displacement, the method that we're using right now, in order to find the volume of an unknown object, the object's density must be greater than the density of water. If you're going to use water displacement to find volume, then the object's density has to be greater than the density of water. Remember, more dense sinks in less dense. More dense sinks in less dense. That's why hot air rises to the top of a room's level while cool air is at the bottom, right? Less dense air on the top, more dense air on the bottom. We've already seen the instructional video, or hopefully you've already seen the instructional video, so let's just go to a walkthrough of the calculations and the type of data you'll be looking at in today's lab. Okay, quick review. Density, remember, is mass divided by volume. So to determine the density of an object, we need to know its mass, which we can establish very easily using a balance. And then we need to know the volume. And the volume is what we're focusing on in today's experiment by using water displacement. To determine volume by water displacement, what we do is we get a graduated cylinder. We place an initial amount of water in there. We then drop our object that we're wanting to determine the volume of into that graduated cylinder, and if it's more dense than water, it'll sink to the bottom, causing the water level to rise. We then read that volume level, and the difference in our final and initial volume levels is equal to the volume of the object. So let's run through the calculations here. Also, why don't you write down TARDIS? Write down TARDIS. T-A-R-D-I-S. TARDIS. Alright, I have my graduated cylinder here. You're going to use your imagination that that's a graduated cylinder. And I start off my experiment with 52.1 milliliters of water. So that's my volume initial. Remember, and this is something that will cost you points in the lab, now I've distracted myself. Your graduated cylinder, when you're dealing with a 100 milliliter graduated cylinder or a 50 milliliter graduated cylinder, that graduated cylinder is marked to the nearest milliliter. You should estimate one more significant figure. So all volume should be to the 10th of a milliliter. Alright, so we take this object and we dropped that object in the water. Alright, so I've got an object here. I take my object and I drop it in the water. My object, let's give our object a mass here. Let's give our object a mass of 28.3 grams. So I have a object of, I have a 28.3 gram rock. Actually, let's make this more like our lab numbers. I actually have a rock with a mass of 28.3111 grams. Remember, never disregard sig figs given to you by an instrument until your calculations tell you. So when you take that mass of your unknown, that balance gives you 4 decimal points. So I better see 4 decimal points in your lab book. So I place my rock in my water, and when I place my rock in my water level rises to a new volume of 63.7 milliliters after I place my rock in the water. So that's my volume final. So what is the density of my rock going to be? So now we need to get the volume of my rock. So my final volume was 63.7. My initial volume was 52.1. So that means my rock had a volume of 11.6 milliliters. So that's the volume of my rock. And know what you should do? You should write down the doctor. Write down the doctor. Everybody write down the doctor. Why? Because I'm looking at my Doctor Who action figure at the moment. Alright, so now we have the volume of our unknown object. So to get our density is simply mass over volume, because the world's densest people work at the DMV. So we have a mass of 28.3111 grams. We have a volume of 11.6 milliliters. Punch that into my calculator, and my calculator is going to tell me that it doesn't want to come on. 28.3111 divided by 11.6 gives me 2.440612 is the lie my calculator tells me. I have to pay attention to sig figs now. I had 3 sig figs in my bottom measurement. I had 5 sig figs in my top measurement. Since I'm doing a division, I'm going to use my least number. So I'm going to have 3 sig figs, 1, 2, 3, round on the basis of the 0. So my final answer for my density of my unknown object is 2.44 grams per milliliter. And chemistry is easy and life is hard, yes? Straightforward, easy to do experiment.